अभी स्टार्ट करते हैं एक्सपेरिमेंट नंबर 8। टाइटल ऑफ एक्सपेरिमेंट इज एनालॉग टू डिजिटल कन्वर्टर इंटरफेस। ओके, तो एनालॉग टू डिजिटल कन्वर्शन कैरी आउट करना है। तो सी द थेरोटिकल वन हियर DAC ADC IC 0809 आपको यहाँ पर रिक्वायर्ड रहेगा। यहाँ ADC चाहिए था, सो दैट्स वाई सी ADC IC हम यहाँ लर्न करने जा रहे हैं। तो ADC IC 0809 आपको डायग्राम में दिखाई देगा। ओके, जस्ट आई हाईलाइटेड इट। दिस IC हैज टोटल 8 channels. Okay, so that's why in the feature it is written 8 channel multiplexer with address logic. Okay, means आप जिस चैनल को यूज करना चाहते हो, टोटल 8 चैनल अवेलेबल हैं और 8 चैनल अगर आपको एक आधा उसमें से यूज करना है तो आपको एड्रेस लॉजिक का यूटिलाइजेशन करना पड़ेगा। वो एड्रेस लॉजिक के द्वारा आप वो पर्टिकुलर चैनल सिलेक्ट कर सकते हैं। तो उसका चैनल सिलेक्शन टेबल आपको नीचे दे के रखा है। एग्जाम्पल, आपको चैनल नंबर 0 यूज करना है तो ABC आर द एड्रेस लाइन्स। आउट ऑफ दिस ABC एड्रेस लाइन्स यू नीड टू पुट अ लॉजिक 0 एंड लॉजिक 1 कॉम्बिनेशन। मीन्स 0 is written as 0 0 0, so that's why ABC line are 0 LLL, then 0 0 1 is written as LLH, then 0 1 0 is written as LHL, then 0 1 1 is written as LHH, 1 0 0 is written as HLL, 1 0 1 is written as HLH, 1 1 0 is written as HHL, and 1 1 1 means it is equivalent to 7, it is written as HHH. Now see, from 0 0 0 to 1 1 1 means total 8 steps. These are available under address lines. These are used for selections of channels. So IN0 required 0 0 0, IN1 required 0 0 1, and so on. So total 8 channels are there from IN0 to IN7. Okay, so in the side here you can see dual in line package IC, that is ADC IC 0809. Here IN0 is a pin number 26, IN1 is pin number 27, then IN2 is pin number 28, then IN3 is pin number 1, 2 is IN4, 3 is IN5, 4 is okay, 6 is 4 is IN6, and 5 is IN7. Total 8 channels are there, and pin number 23, 24 and 25 are saying address CBA, right? सो दैट्स वाई जो लाइन्स हमने यहाँ पर टेबल के द्वारा देखी वह लाइन्स आपको आईसी में इस तरह अवेलेबल है। अभी ये ABC लाइन अगर यूज करनी रहेगी और आपने LLL अगर पास किया तो आपको रिक्वायर्ड रहेगा ALE लाइन का यूज करना। ALE बोले तो एड्रेस लैच एनेबल। ये एड्रेस लैच एनेबल ये लाइन का पर्पज है व्हेन इट इज 0 और व्हेन इट इज 1। ओके, so when it is 1, then the bits which are available over CBA are get putted over the internal circuitry, and a specified channel will be enabled by ADC IC. Okay, see, got the meaning of ALE now? Okay, here I have given you the table. Okay, in that table I have mentioned all the lines. See, I am saying you one by one. Okay, I read IN0 to IN7 ABC, then ALE, right? Now I am telling you about the start. Now start means start of conversion. This is a start of conversion pulse signal. The purpose of this signal is to inform the ADC to start the process of conversion of analog signal which are available over the analog lines or over the channel. That signal are get converted, and after converting this signal, put it over the digital lines of this IC. Okay, so it accept analog signal from a specified channel and convert it, and in the converted signal makes available over the digital bits. Okay, so here a conversion time is also given. In this conversion time you can able to see how much amount of the time taken by the IC. So that's why here 100 nanosecond will be the time given by the manufacturer. That time indicate that conversion time of the IC. Then clock is there. Clock terminal is used for applying the clock signal. Generally the clock signal of range 10 kilohertz to 1280 kilohertz is applied for the operation of the IC. Okay, whenever we are going to convert one form of signal into the another form of signal, that time the ADC IC will require the conversion, we require the clock pulses. So that's why over that clock's input and the frequency of the clock, okay, that signal is get converted from analog to digital. Okay, then V reference plus V reference minus is there. Again I said you in the DAC here for getting the unipolar or bipolar signal. Okay, that's why this V reference and minus V reference is taken in consideration. Then D0 to D7 are the bits. These bits are giving you a digital output. Okay, so that digital output is obtained with the help of this particular D0 to D7 lines. Then EOC line is there. EOC is a end of conversion. Means whenever this DAC IC will convert the digital signal, okay, convert the analog signal into the digital one, that time the end of conversion pulse will be generated by this IC. This IC informs microcontroller that the IC, ADC IC has converted the analog signal into digital one. Okay, so that's why this EOC signal will be available. Okay, then OE is a output buffer enable. This signal is necessary whenever the ADC IC puts the digital data over the output line. So this signal is used to read the digital data from the output buffer. Okay, as soon as EOC signal will be available. Okay, then VCC with respect to ground, generally here it is a plus 5 volt with respect to ground. This signal is necessary for the turn on of the IC, right? So this is about the ADC IC 0809. Okay, now we are going for the interfacing. Okay, so here you can see the interfacing diagram. In this interfacing diagram, ADC is interfaced with 8051, okay, microcontroller. Okay, so here D0 to D7 are the data lines. That lines are interfaced with P1.0 to P1.7. Similarly, P2.0, P2.1, P2.2 are connected with address lines A, B, C, because from the microcontroller you have option to select a address lines, means you can able to select a specific channel. That's why these selections of channel is done through your program, and you have to mention that which channel you want to enable. So that's why you are going to pass the specified bits of the channel from microcontroller pins. So that's why you can program P2.0, P2.1 and P2.2. So the bits are available over these lines, and then you can able to enable the specific channel. Then P2.3 is used for start of signal. The start of conversion pulse is generated from 8051. Okay, so that's why whenever microcontroller will send a start of conversion pulse, the specific channel analog signal are read by the A to D converter, and the ADC IC accept that analog signal, convert it into the digital one, and after converting it into the digital one, EOC signal is generated by the ADC 0809. Once it generate the EOC signal, P2.6 will be monitored by user program to understand the ADC did the conversion of analog signal into digital one, and now digital data is available over the P1.0 to P1.7. So this is about the interfacing. Now we are going to see how the program is executed. Okay. Now see, I am copying the program. Okay. On this simulator, right? Now the program is available. Now I save it. ADC, just save it. Now just run it. Okay, now here see, if you are able to see ADC, okay, here you can see the movement, okay, of this slider. Okay, as you move the slider, okay, the ADC signal means analog signals are get generated, right? So when it is when the slider is on the nil position and a zeros position, so zero voltage is generated. As you move it to the higher one side, the higher voltage is also generated. The last position is 5 volt and minimum position is 0 volt. Okay, now we are going to enable this ADC. Okay, and over the scope you can able to see the output. Okay, over the scope you can able to see its digital value, means what analog signal we are passing to the microcontroller, and what microcontroller will generate a digital data, and that digital data is again displayed over this DAC. Okay, that scope. Okay, see, we do it these things practically. Now I am running. Okay, as I run, immediately see the ADC is now enabled. Okay, and here over the scope you can able to see the red line is running. Red line is continuously monitoring here that no analog signal is there, and here you can able to see over the bottom side a green line is there. Okay, that green line is showing here 0 voltage is available. Now just I touch it, this potentiometer slightly. Okay, immediately you will see 0.12 volt will be there, as 0.12 volt will be available over this scope. And if you observe, the green line is slightly moved from this 0th position. Now I move it again. See, as I am moving this slider, immediately that green line is also moving upside. See, and as well as the digital bits. Okay, that digital bits are get displayed over the screen, that is 4.08 volt. Okay, as well as 4.18, 4.32, 4.59 and so on up to 5 volt. See, you can see the green line over the scope also. Okay, just I am wearing these. Okay, you can able to see the variation ओवर दिस. ओके, जैसे मैं यहाँ पर स्लाइडर को मूव कर रहा हूँ वैसे वैसे साइड बाय साइड आपको यहाँ पर वह स्कोप के ऊपर वह सिग्नल मूव होते हुए दिखाई दे रहा है. गेटिंग एवरीवन? ओके, बहुत इंटरेस्टिंग है ना, बहुत अच्छा है. ओके, तो इस तरह आप इस सिमुलेटर के ऊपर ये एडीसी का एक्सपेरिमेंट यहाँ पर परफॉर्म कर सकते हो. ओके, तो अभी मैंने यहाँ पर प्रोग्राम को एक्सप्लेन नहीं किया. वंस इन आवर थियोरेटिकल सेशन, ओके, यू कैन see the program also. Okay, so see, this is about the ADC. Okay, I hope you do it this ADC over your simulator, your desktop and laptop if you have installed it. Otherwise use your friend's laptop or computer. Okay, and do it this experiment thoroughly. Okay, so at this time I am just quitting this experiment. Okay, now